Hello, my name is Jessica Robles, and for my Cyber Academy project, I did a secure network design project with my mentor, Manohar Ravi, through the University of Colorado, Colorado Springs. I will be going over the introduction, the goal statement for my project, the midterm recap, the work that I did, the results that I have gotten from my project, the future work, and the conclusion. Essentially, my project was to design, develop, and implement a secure network using virtual local area networks, also known as VLANs. A VLAN is a virtual local area network. It pretty much is a network of computers located within the same area. They could also be a group of devices on one or more local area networks configured to communicate as if they were on the same wire. The ultimate goal was to design and implement a network with VLANs and implement multiple VLANs on one singular switch. To begin my journey in networking, I had to learn about networking and learn about the Cisco Packet Tracer and utilize the different devices within the Cisco Packet Tracer, such as hub, switch, and router. And as you can see, the hub is on the left, the switch is in the middle, and the router is on the right. Before the final product, I had designed a simple network design that is shown here with two PCs connected to a singular switch. Since that simple design, I had expanded on it by adding more VLANs and PCs. And as you can see, there are a lot more PCs connected to one switch. And next to each PC, they're labeled with different VLANs, either VLAN 10, 20, or 30. After I had designed the more advanced network, I had assigned IP addresses to each specific PC. In addition to assigning submasks for every PC, and finally, I added a gateway IP address for each PC. Now, through the Cisco configuration, I had assigned names to each VLAN, and VLAN 10 is labeled as finance, VLAN 20 is labeled as sales, and VLAN 30 is labeled as marketing. Having different labels for each VLAN is very helpful in an organization to figure out which department is which VLAN, so nothing is confusing and nothing gets mixed up between different VLANs. Now, in order to actually designate the VLANs to the PCs, I had to use multiple Cisco commands within the Cisco configuration. And the first one that I used was the command enable. This enables the privilege exec mode, which leads into the next command, which is config, short for configure. This enables the global configuration. Next, the next command is interface FA0/1, which is short for interface fast Ethernet 0/1. The number indicates which interface the PC is connected to, but this command enables the interface configuration. The next command is switch port access VLAN. This command configures the VLAN, which assigns the VLAN to the PC. After you configure it, the no shut command is used, short for no shutdown. This supports the prior command, switch port access, which restarts that interface after the configuration. And finally, the last command is exit. This exits the interface configuration, which creates a blank slate in order to create more configurations with new VLANs and PCs. The results are shown here. The PC, it is seen that the PCs on the same VLAN can ping each other, in which the arrow is showing that two PCs from the same VLAN are communicating with each other and they are sending and replying. Now, this arrow shows that a PC had tried to communicate with a different PC on another VLAN, and it shows that the request was timed out. This shows that PCs can only communicate on the same VLAN. This creates a more secure network and leaves the same info in the same VLAN. Now, to add on to this project, VLAN trunking can be used, which is in addition to the switch, it can be a VLAN across a network, or you can have multiple VLANs on one interface. In addition to the design that I had already shown, I could add more routers and more switches to the design, and also a lot more VLANs. And after you doing this project, I can use this knowledge for my future jobs. And in conclusion, I can implement the network. I implemented this network with multiple VLANs, and the VLANs allow for more secure networks. This means that the only information that is sent between the PCs in the same VLAN are only represented in that VLAN. It's not shown in any other devices, which less people have more access to. VLANs allow organizations to be more cost efficient. Because you can have multiple PCs on certain VLANs, you're using less hardware, which allows for more flexibility with the cost. And finally, the results show that the devices in one VLAN can communicate with each other, but not with devices in another VLAN. Thank you.